What's up, everyone? This is LeetCode 973, K closest points to origin. We're doing this problem in C++. Done it in Python already. But we're going to do this problem in C++ now. So we're given an array of points where points of I, x1, y1 represents a point in the xy plane and an integer k. Return the k closest points to the origin 0, 0. Okay, so what this problem is basically asking you is we have a bunch of coordinate points, right? And we have to return the k closest points. So let's say there's 10 points scattered and k is equal to 3. We would return the 3 closest points closest to the origin 0, 0. And we use this Euclidean distance formula here to calculate the distance, okay? So we're going to go through example 1, right? We have 1, 3, we have 2, okay? So using the formula, we would do 0 minus 1, square that, we get 1, plus 0 minus 3 is 3, square that, we get 9, so we get 10, okay? Now, the second point here, 0 minus 2, 0 minus negative 2 is 2. Square that, we get 4, 0 minus 2 is negative 2. Negative 2 squared is 4 as well, so we get 8. Okay, 4 plus 4 is 8. So this point here is closer to the origin. So when we have k is equal to 1, we have to return this, okay, because it's closer to 0. Now, if k is equal to 2, we'd return this, and then return this, right, because this one's further away. So a way to approach this problem, right, like a naive approach, would be basically calculating the z, right? Let's say this formula gives you a result called z. Calculating the z for all these points, sorting that, and then returning the lowest values up to k, right? Now the problem with that though is you're calculating a bunch of points, or you're sorting a bunch of points you might not use, right? For example, if we do that for here, example 2, we're only returning k is equal to 2, right? But we would be sorting 3 points, so we're adding a lot of overhead using that approach, right? So that would not be the proper approach. The proper approach actually is just to use a min heap, right? It's more efficient. Okay, so we're going to do that. So we're going to say sort eq okay, just like that. It's kind of wordy. But it's okay. So we create our min heap, right? And we need to have a vector for our output. Vector. Okay. Now here's where we do the calculation, okay? So here we would do calculate calculate the square distance, store it in the heap, right? And up here we're just creating our min heap and our serve. Okay. Just making sure I comment my stuff so you know what's going on. Okay, so now we're gonna iterate through the points here and use Euclidean formula, okay? So we're gonna say x is 0.0. Let's say y is 0.1 first index, right? Because it's a pair. I'm gonna say z is equal to x times x, right? Y times y. Now, obviously there is a square root here, but I didn't do that, right, in the example, because it adds overhead. We don't want overhead, right? It's just unnecessary computation, because if we have we calculate a z like this, 8 and 10, the square root of 10 is always going to be bigger than the square root of 8. Namely, what I'm basically saying is that the square root of some value x is always going to be less than the square root of some value x plus 1 or whatever, right? X plus some integer. So my point is, like, when you have numbers, when we calculate the z, we don't need to take the square root because the square root of a number is always going to be bigger than the square root of a smaller number, right? Meaning square root of 10 is going to be bigger than square root of 8, right? So we don't need to take the square root. It's just kind of, it's a bit redundant for this problem, okay? It's just adding overhead and computation that we don't need. Okay, so calculate z, and we're going to say min heap. Okay, we're going to add z and then the pair coordinate xy, okay? Because we use z to calculate the closest points to the origin, but in our actual output, we need to include the actual coordinate pair, okay? Not the z. The z is just for calculating which ones are closest to the actual origin, okay? So do that there. Okay. And then we extract the k closest points. So we're going to say while k is greater than 0 and the min heap's not empty, we're going to get auto be the point. We're going to say min heap dot pop. And again, we need to include this as a pair, right? So we're going to say point dot first, point dot second. Okay, now what we can actually do is we can remove this here, right? Because we need to decrement the k after we pop every time, right? So we're going to just say k minus minus. Okay, post order or post decrement. And again, what we're doing is we're calculating the z's, right? Putting them in a heap, in a min heap, and naturally the min heap will, when we pop for the min heap, we'll get the point closest to the k, closest to the origin. In the min heap, obviously the points are ordered such that the points closest to the origin are popped first, right? So if k is equal to 3, we just pop the first 3 and put that into the resulting array, okay? And yeah, k will always be less than or equal to however many points we have, right? So we don't have to worry about any like weird edge cases that might break our program. Okay, pretty simple. Const auto. Sorry, I said pair, but I used the variable point right here. Also, there should not be a comma either. Just little errors. C++ is very verbose and specific. But, you know, that's kind of that is a power the language has. I think this problem really is a knowledge check on min heaps, honestly. Just in heaps in general. So I don't think this solution or approach is anything special, because like you can, even though it'd be less efficient, you can just like find the z for every point, sort them, and then take the k points from the sorted list, right? A min heap is just a little bit more of an efficient way to approach that problem, but the approaches are kind of similar in nature. One is just less efficient, right? I'll be honest, this problem is probably the easiest medium problem on the grind 75 list, so because you can solve it a little bit inefficiently, and still solve it, right? So I think this problem honestly is just a knowledge check on heaps. But if you don't know min heaps, that's okay, right? Just review it, put it in your back pocket, because you'll be using it in a bunch of different problems. So yeah, I hope this helped, and I'll see you in the next one. Peace out.